In lecture number 4 from the chapter Acids, Bases and Salts, we are going to study about what are salts? Do the salts have families? If yes, what are the families of salts? And how do we identify the nature of salts? When I say how do we identify the nature of salts means that just like acids are acidic, bases are basic, water is neutral. Similarly, salts can also be acidic, basic or neutral. So we'll understand how to identify the salts as acidic salts, basic salts and neutral salts in this video. So first of all, let us understand what is a salt. We have already studied about neutralization reaction in chapter number 1 as well as in the current chapter. So a salt is formed whenever an acid reacts with a base or whenever an acid and a base undergo a neutralization reaction. So if we look at the formula of any salt, let us take up a very simple salt here, the most common one, that is sodium chloride, NaCl. There are two parts present in it, the positive ion and the negative ion. So the positive ion is known as the cation and the negative ion is known as the anion. So if we split sodium chloride, we get Na positive and we get Cl negative. So sodium ion here is the cation which is derived from a metal. So metallic part is always the cation and the chloride part is the non-metallic part which carries a negative charge on it and it is the anion. So remember that whenever we have a neutralization reaction, let's say these two salts have been formed with the combination of HCl and NaOH. So when these two react, we get NaCl because sodium comes from the base and chloride comes from the acid. So NaCl and we get water. So if we have a formula of a salt and we want to know like from which acid and base that particular salt has been formed, what do we do? To the metal part, simply add OH negative and to the non-metal part, add H positive. So what do you get? You get NaOH as the base and HCl as the acid. So that is how you can identify using the formula of the salt from which acid and base a particular salt has been formed. Also, just like we have two families, the maternal family and the paternal family, the family of our mother's side and the family of our father's side. Similarly, salts also have two families, the cationic family, that is the family of the metal part, and the anionic family, the family of the non-metal part. Let's understand this more. So as we said, nature of the salts, we are going to talk about nature of the salts in this video. Strong acids and strong bases, when they react, we get a neutral salt. Similarly, if both the acid and both the base both are weak, in that case also we get a neutral salt. So if the strength of the acid and the base both are strong or both are weak, in both the cases you will get a neutral salt. But if the acid is strong and the base is weak, you will get an acidic salt because the acid is strong. So obviously the stronger one dominates. But if the base is strong and the acid is weak, then we get a basic salt because the base is strong. So whichever is strong, that kind of salt will be formed. But if the strength is same, both strong or both weak, in that case we get a neutral salt. Now you must be wondering what are strong acids and how do we identify whether a given acid is strong or weak. So for that, I have already told you earlier also that there are just three acids which are strong. So if you remember the names, all other acids other than the three that I am writing here, that is HCl, H2SO4 and HNO3. These are the three strong acids. And you have just two bases that are strong, that is NaOH and KOH. So other than these two, all the other bases that you have are going to be weak. So you don't have to remember the names of the weak acids or the weak bases. You just have to remember the names of the strong acids and the strong bases that will help you in solving the problem. Let us take up some examples now based on this. So you can see there's a table on your screen on which names of certain salts are given. So first we will write down the formula of the salt. Like for sodium chloride, it's NaCl, and we have already seen that, okay, for the base part we will be writing the metal part, that is Na, and for the acid part we'll be writing the non-metal part, that is Cl. And with Na you will write OH, and with Cl you write H. Now, based on what we discussed on the previous slide, HCl is a strong acid and NaOH is a strong base. So when both the acid and the base are strong, the nature of the salt would be neutral. Let us do one more example. Potassium chloride. So the formula that you get is KCl. We write K for the base and Cl for the acid. And with Cl we put H, and with K we use OH. Again, both the acid and the base are strong. So we get a neutral salt again. Third one, sodium carbonate. What is the formula of sodium carbonate? It's Na2CO3. That is the formula. Now we write Na under the base and we write CO3 for the acid. Now we know the valency of carbonate is -2. How do we write carbonates? It's CO3 -2. So because there are two negative, we need to put two hydrogen in order to balance the -2 so that the molecule on the whole becomes neutral. So the formula here would be H2CO3, that is carbonic acid. And with Na, we know that because sodium has a +1 charge, so one OH is enough. Plus and minus, they balance each other. Now, can you identify? I said only three acids are there that are strong: HCl, H2SO4 and HNO3. So H2CO3 is not one of the strong acids. That means it's a weak acid here, but the base that you have here is strong. So the nature of the salt would be basic because the base used here is a strong base. Likewise, you can do the next one. Magnesium sulfate. The formula is MgSO4. So magnesium under the base and sulfate under the acid. Again, SO4 carries a 2 negative charge, so we will be using 2 hydrogen here. That makes it H2SO4, sulfuric acid, a strong acid. And magnesium also has a charge of 2 plus. So the valency of magnesium is 2 plus. So we need 2 OH negative to balance that 2 plus charge. So the formula becomes MgOH whole twice. Now on close observation we find that the acid here is strong. So the nature of the salt here would be acidic. Moving on to the next one. Calcium carbonate. It's CaCO3. That is the formula. Calcium will form the base and carbonate will form the acid. So we put a H2 here because again the valency of carbonate is -2. And with calcium we need to put OH twice because the valency of calcium is also 2. And we see that both the acid and the base used here are weak. And if both are weak, then also we get a neutral salt. The last one is ammonium nitrate. So what is the formula of ammonium nitrate? Ammonium nitrate is NH4NO3. Now you'll be wondering what to do because you don't see a metal here. So ammonium, since it carries a positive charge, it would be placed under the base category. And nitrate, since it carries a negative charge, it will be placed under the acid category. So we put an H here and we put OH here, and we find the acid is strong and the base is weak. So the nature of the salt will be acidic. So I have brought some examples for you. Now you can try it yourself. You can pick up formula of salts yourself and try identifying which acid and which base have resulted in the formation of that salt, and then identify whether it's acidic, basic or neutral. Now, as far as the uses of salts are concerned, salts are an inseparable part of our lives because there are so many uses of salts, out of which I've just picked up a few of them here. Like sodium chloride is the common table salt that we all use in our cooking, in our food, as a preservative, as a taste enhancer. Then sodium chloride is also a raw material used for obtaining many other substances, like for getting sodium, for getting chlorine. Then ammonium nitrate and ammonium sulfate are salts that are used in the manufacture of fertilizers for the plants. Similarly, magnesium sulfate, which is commonly known as the Epsom salt, is also used as a bath salt. In the next video, we'll be studying in detail about some more very important salts that are a part of your syllabus. So once you are thorough with the concept of salts, don't forget to watch the last part of this chapter, in which we'll be discussing in detail some very important salts such as baking soda, washing soda, plaster of Paris, sodium chloride, and some more.